The latest lockdown has shown the limitations in physical laboratories and the need for a virtual platform where students can continuously continue their education without any interruption. Hello everyone, my name is Anthony Khouri, and today we'll be discussing educational applications on smartphone for virtual laboratories in engineering. Now let's begin. Now, virtual laboratories have been known for their ease of access and scalability, the removal of workflow obstructions, and the potential for resource and data sharing. However, one of the main disadvantages lie in the lack of hands-on physical work and the required knowledge to use the applications. As for the challenges behind the development of virtual laboratories, one of the main challenges is in the modeling phase, where there are two main modeling methods. The first is the mathematical modeling. However, when a mathematical model isn't present or difficult to implement, the experiment can simply be replicated and the data table can be inserted into the application. Another challenge lies in the platform development, where there are two required expertise to develop the application. The first is a scientific expertise in the actual laboratory, and the second is a software development and informatic expertise. As for the other challenges, one of the challenges lies in the user experience, where there are two knowledge barriers to operate the application by the user. The first is the knowledge of the laboratory, and the second is the knowledge of the application itself. There's always the challenge related to the presentation, which is concerning the extensions and animations that are used in order to immerse the user in the experience. As for the final challenge and concern, it concerns the system requirements, where, as any other application, the virtual laboratory must meet the minimum requirements that are set by the hosting platform. Now, after seeing the challenges, it's time to move on to the solutions. These solutions are presented by a set of virtual laboratory applications that were developed by the authors. For the first challenge of modeling, the approach is explored in developed electronic engineering virtual lab for elevator control, and the solution is a combination of two different modeling methods. The first concerns the digital logic control of the elevator, and the second concerns the mechanical control scheme of the elevator. As for the challenge of the platform development, the virtual lab in study here is a machine learning lab, and the solution is a form layout builder, which is a self-coded application that eases the creation process of standard form. As for the challenge of augmented reality for presentation, this is explored through the virtual lab for fluid friction testing, and the solution is the development model of a BASIX hydraulics bench HM150, which is a standard model that is used and easily recognized by the user in the industry. Concerning the challenge of the user experience, the virtual lab used to explore the solution is based on the lab of concrete mix design. Now, the approach presented by the application is based on the standard approach followed by engineers during fieldwork. An optimal user experience is to enable the user to successfully conduct the task without any form of confusion or need for trial and error, while also offering the results in a quick and convenient manner. The needed input parameters are based on the standard parameters in the industry where the user would be fully aware of. As for the final challenge with the system requirements, this challenge is studied through the developed virtual lab of permeability testing. This test is mainly employed in the fields of petrochemical and civil engineering. Now, the solution here is based on two approaches. The first approach is the removal of dependency on programming languages, where this lab relies on providing the user with all of the standard models in the domain in order to replicate any desired scenario. At the start, the user is automatically introduced to the choice of method, and then the entire set of parameters is provided for the user to calibrate without the need for any other function. The second approach is the optimization of the memory cost of the user interface, where the design of UI aims to guide the user from the beginning of the experiment to the end. Graphical user interfaces in scientific applications tend to be heavy in performance demands because of the standard amount of information and data that needs to be displayed. This solution is based on the design of a varied set of separate sub-interfaces dedicated to each of the possible scenarios that the user wishes to test. In addition, the step-by-step filtering of the data to be used and methods reduce the memory costs behind simultaneously displaying and utilizing all the resources needed. Now, virtual laboratories have seen a growing interest in the industry. And with the continuous development towards ubiquitous learning and increasing accessibility in education, the smartphone offers optimal support. However, this transition requires a different culture of thought in order to successfully pass this phase. Now, as always, thank you for your time and listening, and I hope you have a good day. Goodbye.